All right, students, this is the video for Math 3, Section 4.3. We're going to be graphing square root of x and cube root of x. So a couple things first before we graph them. We're mainly going to be using Desmos, but we should talk about what the main shape of this is first. So we'll want a table of values. Now, with this table of values, what happens is we cannot square root the negative 1. We cannot take the square root of negative 1 at this point. If you put it into your calculator, it will tell you math error. All right, we will get to that. There is an answer, but we're not going to talk about it right now. So what that means for our graph, we're going to start at 0, and then 1, and then 2. And so like if I plug in 0, square root of 0 is 0. Square root of 1 is 1. Square root of 2 is a decimal. You can put it into the calculator, and it's about 1.4, approximately. So if you don't have a calculator, what you can do with this one, square roots, is go with 4 and 9 and 16, 25 if you want to make your graph that big. All right. The main thing is, though, it starts at 0, 0, and it goes on from there. So your graph would start at 0, 0, and then go on from there. Okay, I'm just doing a quick sketch here for our purposes. What it would do, though, is it go through 1, 1, 2, 3, 4, and at 4, 2, right around there. 1, 1, 2, 3, 4, 4, 2, like we said. And something like that. But it would not go into the negative. That's the main thing we want to see about this thing. This one, however, you could do a negative. It could go into the negative. So they're sort of related, but not exactly. Because with this one, you could do negative 8, negative 1, 0, 1. Negative 8, the cube root of negative 8 happens to be negative 2. Because a negative, negative, negative would give you negative 8. Negative 1, 0, 1, and 2. So the difference with that graph is it looks more like, shoot, should have gone through 0, 0. There we go. Okay, so that's the general shape of it. Okay, but it does go through 0, 0, that's for sure. And what we're going to focus on then in this chapter is how to shift it. Okay, so what if I took this original equation and what if I put a number inside? Well, it turns out it would have the same effect on both graphs. What if I put a number on the outside? What if I added a number on the outside? It turns out it would have the same effect on both graphs. And that's what we're going to see by playing around with Desmos. So here I am in Desmos, and we're going to start with the square root of x. And so I need the calculator on Desmos, sorry, the keyboard on Desmos, and x. Okay, so start with that. And then I'll do that so it makes it a little darker. So the key thing here is it starts at 0, 0. It does not go any lower than 0, 0. It cannot go to the negative. However, we can shift it down. And this is what we've done before. If you subtract a number at the end, it shifts it downward. All right, so if we put -5, it shifts it down by 5. And if you think about that, our new point, our new 0 for x, when you plug in 0 for x, would be -5. It would be right there. When you plug in 0 for x, you would get -5. So that's sort of why it does it. If I change this to +5, then it's up there. This should look familiar because we've done this before. This is exactly what we did with parabolas. So if you learn it well for parabolas, it doesn't matter that this is square root. The rule is the same. A plus at the end would do the same change to it. Okay. Now if you go down here on the functions keyboard and pull up, this is where you can get to the nth root. It doesn't have to be a square root. Now we can put a third root of x. And there's that shape I mentioned. The idea with this is not to have an exact graph, but to know sort of it looks like that. That x cubed does go left and right forever, and x squared sorry, square root of x, not x root. Square root of x just goes on in one direction. Okay, so but x cubed, sorry, cubed root of x goes on forever. Okay, so now what we can do is we can shift this thing up and down just the same. So if we go plus 5 on here, just like before, it shifts the entire thing up 5. Okay, let me get rid of that original one. And then, if we put a number inside, let's take out this plus 5 here, and inside the parentheses, put a minus 5. Okay, so let's think about that. Copy that and paste it. Let's go back, put the original. Take out that minus 5. The original, take a look, here's the key. The original went through 0, 0. The new one goes through 0, 5. And the reason for that is because even though it's minus 5, you got to think that this was 0, 0. Okay. You don't think about the minus 5, you think what makes it 0? What would make that radical 0? And the radical would be 0 when x equals 5. When x equals 5, your y value would be 0. So, that's why it goes from 0, 0 to positive 5. Again, it's backwards. Okay. Now, when we subtract a number at the end, though, that's different. Then that shifts it down. So again, that is different. Notice I put a minus 5 now. In that case, when you plug in 0, you get a negative 5. Okay. So you got to think about it. It's different for when it's inside or when it's outside. Okay. Now, to make this a little bit easier, another thing, or it's sort of a, I don't know if it's easier, but this is what the book does. Instead of calling this y equals, they call it f of x. And then I can just say f of x minus 5. And that's that graph there. Let's see what that is. This notation, when you get used to it, whoops, I'll get rid of that. This notation, when you get used to it, this thing is what's plugged in there. So you don't have to keep on writing the whole cube root notation, which is not easy. All right. Let's get that out of there. And again, let's try this again. If I did f of x minus 5 this way, now it's down 5. Okay, so that's a big distinction. That's a big distinction for us. Whether it's inside or whether it's outside. Okay, inside would be happening inside the radical. Outside would be happening outside. All right. So we've learned all that stuff before. Okay, and we just got to get used to this f of x notation. And once you do, you can see the advantage to it is you don't have to write this whole cube root notation again. Let's do one last thing here. Let me turn these ones. Just get rid of them. X them out. Let's do this. Let's say we multiply this thing by 1/4. That's like multiplying our equation by 1/4, but I don't want to type that whole dang thing again. Whoops, not like that. F of x. Like that. Notice that shrunk it. That's what we call a vertical compression. Okay? You can sort of think of it in terms of slope, but it's not slope. Slope is for straight lines, but the steepness, yes, the steepness did change by 1/4. So if we crank that up to 4, whoa, it gets 4 times as steep. Okay? Everything, or you can think about everything got multiplied by 4, so everything went up by 4 times. If it used to be at this, it's now 4 times that. If it used to be at 2, it would now be at 8. So let's assume this was maybe 2, it would now be at about 8. And you can see that on here. Ah, dang it. Let's get rid of this thing. Sorry. You can put in a point. Ah, dang it. And you can put 2 comma, I don't know what 2 gives us. 2 comma f of 2. So it's like x and y. And there it is. There's a point. Hey. And you can even give it a label. My point. Get to the point. Right, there's my point. I've made my point. But all right, thanks for sticking around. I'll be here all week. All right. Let's do the next one. Let's go 2 comma f of... No, sorry, the next one was 4f of x. 4f of 2. Yeah, take a look. Now we have an actual point. And so this can be useful. You can do a table of values. You can do whatever. Oh, we label it as my point. We can label this that point. All right. Anyways, okay. So this is, again, not something I used to like. Not that that matters, but it is confusing is what I was going to say. It is confusing. So what this is like saying 2 comma y. And what's y? Well, y is when you plug in 2. So that's why the f of 2. F of 2 is really just a y value. This one's 4 times that y value. That's what's going on. I know it's kind of confusing. Just got to sort of play around with it. Okay. There's one other way to see this. I can get rid of these points. Bye-bye points. I can add a table. And let me change the order of this because I want it on the bottom. And I'm going to put f of x1. You have to do this, by the way. If they make the table x1, your f of x needs to be f of x1. So what's this doing? Saying, if I plug in 0, it gives me 0. Let's plug in 1. That function will give you 1. Let's plug in 8. Plug in 10. Now you're getting decimals. This is, for me, faster than doing the calculator. So the table on Desmos can get you a lot of values as well. Okay. And again, the advantage here is that you didn't have to retype this equation in here. You can just use the f of x notation. And it's a little bit shorter. All right. So once you get used to f of x, I think you'll find it a little bit better. And well, thanks for watching. Thanks for sticking around. And we'll catch you next time.